The optical technology was investigated a long time ago to, I would say, provide additional features and performance with respect to an electronic technology. But very recently we identified some new, I would say, performances linked to the energy consumption that position this technology as a key technology for this green transition. One particularity of the optical technology, for example, is optical transparency. You can deploy an optical technology like a fiber infrastructure for a long life cycle. You upgrade only using new interfaces, but without changing, in fact, the network infrastructure. And so this is very important also to minimize the energy consumption of a global system. And why we need to pay attention to the energy consumption in this green transition? It's maybe because we have a strong challenge for 2030. In particular, the projections show that if we don't react today, the demand in electricity to the grid could reach a high percentage. And so, since the demand is shared between different sectors, it is then important to create an asymptotic curve to bound this percentage to maximum 15%. It was 11% in 2020, so 15% in 2030 could be a good target. And this target corresponds to a reduction of the prediction we have done, the reduction of the electricity consumption of the ICT by 50%. And so if we want to reach this 50% of energy consumption reduction, we have to think about different technology that will help this green transition. And this optical technology can bring additional added value with respect to the radio frequency. And so this is why today we are considering that this optical technology is extremely is fundamental for this green transition. If we summarize an optical system to a few components, so the first one is a laser. The laser is responsible for the modulation of the data at different bit rates. I will not cite all the material, but we will go through the whole chain. For example, we have the photoreceivers, then we have optical amplifiers. We will have also a system called optical adenome multiplexers. If I do a zoom on the optical amplifier, for the fiber optical amplifier, we need the erbium, the ion erbium 3+ to dope, in fact, the fiber and create, in fact, the possibility to exploit energy transitions in the bandwidth of the telecom channel, so around the 50 nanometers. It's the same for integrated devices like optical adenome multiplexers. We need indium phosphate materials to create this semiconductor optical amplifier that are integrated amplifier with respect to the previous one, which is an amplifier based on fibers that is deployed on transmission systems. We have the silica also, which is I would say the material used for the optical fibers, but this is not a critical material. We can find it very easily, and we can find other material. But for the moment, we don't see any critical material to realize these devices. I would say that the deployment in the field is realized with respect to the demand. And so for the future, as we were saying, so the objective is to have a complementary approach in order to not be focused only on one technology, but to be focused on the multiple technology to be at the optimum in terms of energy consumption at the end-to-end solution level. We already identify the need for new devices. Why? Because by exploiting the energy of photons, we are doing energy savings with respect to the interaction with electrons. So the key question is, what are the functions we can synthesize tomorrow in order to minimize electron interactions in some fundamental functions, like reshaping the signal or designing new devices like optical switches to avoid an electronic processing. This can require probably new material, since we need also to integrate these devices into a platform is really targeted for the integration of different materials and to have very compact chipsets that could be put in systems that will be designed for a very low power consumption. So definitively there is a room for new investigations around the potential of this optical technology. My advice is to be passionate by physics, by the science, in order to really take these challenges as a hobby and really take fun in pushing, in fact, the physics, pushing the possibility of the different technologies to consume less than today. So there is a very strong challenge linked to the economy, linked to also the societal acceptability. And so this is the first recommendation. The second one is to work in the team spirit. So it's really important when tackling these strong challenges to discuss, to interact, and to work in a team spirit, because all the records are made in a team, and so it's important to take also the knowledge of others to increase also our own knowledge. The third one is to be curious also. Curious, not admit always what exists, but try to understand where we have to go, to have a long-term vision, to anticipate things. So this is also very important, except if we are really in a development where we have to go on the specific objective. But in research, it is important to have this long-term vision, to anticipate. And this can create very strong opportunities of collaboration and of new inventions that are required for this green transition.